All right, let's talk about building a smarter AI architecture. We're going to explore how you can move away from those unpredictable runaway API bills and into a fixed rate model that actually gives you a massive competitive edge. But first, let's start with a number. Take a look at this, $2,720. For a lot of folks using commercial APIs, that's what it could cost you every single month just to process 1 billion tokens. And the craziest part? The more successful your app becomes, the higher that number climbs. You're essentially getting penalized for growth. Now, what if you could process that exact same volume and frankly a whole lot more for a predictable flat cost? $868 a month, period. And let's be clear, this isn't about being cheap. This is about being smart. It's about building a high-leverage architecture. It's about avoiding vendor lock-in, getting real financial predictability, and truly owning your own infrastructure. So today, we're going to bridge that gap. Let's dive in. So first things first, before we can talk about the solution, we have to really understand the problem with this standard pay-per-use model. We're calling it the token trap. And trust me, it's a trap that can really hurt an AI application, especially when you start to scale. So here's where it gets really, really interesting. You'd think a token is a token, right? Well, not exactly. There's this kind of hidden trick in how commercial APIs bill you. You see, what you send to the model and what you get back from the model are not priced the same. Not even close. You end up paying a huge premium for the model's response. And this table just lays it all out, clear as day. Look at this. For some of the most popular models, the output tokens, the actual answers your users want, can cost 3, even 4 times more than the input tokens. So if you're building an app that generates detailed answers, maybe using RAG or a conversational bot, this pricing structure is actively working against you. Your success is literally tied to a bigger bill. So the big question is, how do we escape this trap? Well, the path to a fixed-cost world starts with a key technical unlock. It's what makes self-hosting these giant models actually affordable, and that key is quantization. So what on earth is quantization? The easiest way to think about it is like a compression technique for AI models. It shrinks the model's size, its memory footprint, by making the math inside a little less precise. And here's the magic trick. It does this without really hurting the model's performance in any meaningful way. So you get this massive model that can suddenly fit onto much more affordable, accessible hardware. And, just look at this difference. This is the real game changer. A huge 70 billion parameter model normally needs about 140 gigabytes of VRAM. You're talking about a complex, very expensive multi-GPU setup. But after quantization, it drops down to around 40 gigs, and that is the unlock. That's what lets you run this absolute beast of a model on a single rentable enterprise GPU. Okay, fantastic. So we've got our model shrunk down to a manageable size, but that's only half the story, right? Now we have to figure out how to squeeze every last bit of performance out of our hardware. We're paying a fixed cost for this GPU, so we can't let it sit idle. We need a high-throughput engine. And the core innovation that powers these modern engines is something called paged attention. Frameworks like VLLM pioneered this. Think of it like virtual memory, but for your GPU. Instead of blocking off a giant, wasteful chunk of memory for every single request, it breaks it up into tiny little pages. It hands them out dynamically, and as soon as a request is finished, poof, those pages go right back into the pool for the next request. It's incredibly efficient. I love this analogy because it just hits the nail on the head. Why buy a whole pizza when you'll only eat one slice? That's exactly what traditional inference did. It reserved a huge slice of memory for every user, even if they only needed a tiny bit. Paged attention puts a stop to that. You only pay for the slices you actually eat. And this super smart memory management is what enables another incredible technique called continuous batching. Basically, instead of waiting for a whole group of requests to finish, the engine can dynamically swap in a new request the microsecond an old one is done. The end result? Your GPU is constantly working, constantly churning out tokens. You are getting the absolute maximum performance for your fixed cost. So when it comes to choosing your engine, you've got options. If you're going for maximum throughput, and in a fixed cost model, that's really the only metric that matters, you're looking at things like VLLM or TGI. They're built for this kind of production work. Now, if you're just getting started or developing locally, Llama is absolutely fantastic. It's incredibly easy to use. All right, let's put all the pieces together.
We have our quantized model that can fit on a single GPU. We have our super efficient, high-throughput engine to run it. Now let's assemble the whole thing, our high-leverage architecture built on a predictable, fixed monthly cost.
Now, where do you get the hardware? Here's a pro tip. Don't go to the big, general-purpose cloud providers. You'll find much better deals at specialized GPU cloud providers. For this job, the NVIDIA A100 with 80 gigs of VRAM is the sweet spot. It gives us plenty of room for a 40-gig quantized model and its cache, and it's all on a single card. No complicated multi-GPU setups to deal with. And now, for the beautiful, simple napkin math. That GPU runs for about $1.19 an hour. Multiply that by the hours in a month, and you land right at our magic number, roughly $868. That's it. That's your bill. It doesn't matter if you generate 1 billion tokens or 10 billion tokens. The cost is fixed. This predictable fixed cost is what allows us to do something really powerful. It lets us calculate the financial arbitrage, the exact point where self-hosting stops being just an experiment and becomes a massive money-saving competitive advantage. So, to make a fair comparison, we need to figure out our internal price per million tokens. We'll call this our equivalent token cost, or ETC. It's simple. We take our fixed hardware cost and divide it by our throughput. And we'll be pretty conservative and assume we're getting around 400 tokens per second, which is easily achievable with this kind of setup. And when you run the numbers, wow, the difference is just stark. Our self-hosted ETC comes out to about 83 cents per million tokens. Compare that to the blended API rate of $2.72. It's not even in the same ballpark. And this lets us calculate a very clear break-even point. So here it is. This is the bottom line. 319 million tokens per month. Once your application processes more than that a month, you are actively saving money. Every single token you generate beyond that point is just increasing your ROI. But this is about so much more than just the direct monthly savings. When you adopt an architecture like this, you're building a lasting strategic moat around your business. You're giving yourself freedoms that your competitors are just not going to have. I mean, think about it. You get cost elasticity, you can build that wild token-hungry feature you've been dreaming about without fearing a 5-figure bill, you get absolute financial predictability, and you get total data sovereignty. The data never leaves your control, which is huge for compliance. Over time, this whole platform becomes a capitalized asset that just keeps delivering value. And that leaves us with a final thought to chew on. This whole thing starts with saving money, but it ends with unlocking potential. When the marginal cost to generate one more token gets incredibly, ridiculously close to zero, what will you build? What new products, what new features, what amazing user experiences become possible when the cost of generation is no longer holding you back?